Right. In this chapter, basically, so we will be discussing about solving a problem using computer, means developing an algorithm. Algorithm means a methodology. So, to solve a problem, it's not possible to solve it at once. You have to divide it to small areas and then identify different inputs, outputs, and processes, decisions related to it. And then you can easily solve a problem. So that is where the algorithm comes. Algorithm is step-by-step process to solve a problem. Then control structure means there are three control structures. Can you remember anything like that? Control structures. There are three control structures basically.
Um, sequence selection.
Sequence selection and repetition. Yes, those are the three control structures available in programming. And sequence, in case like sequence means instructions are executed. Instructions executed one after the another in sequential order. That is called sequence. But if you are having a decision to be taken, the instruction flow is depend on a decision, then we call selection. So for an example, you came from grade 1 to grade 11 through sequence. So after grade 1, you have grade 2, then grade 3, grade 4, likewise. Now we are in grade 11. So that is sequence, one after the another. But in grade 11, basically in grade 12, you have to select your subject scheme, either mathematics or science or commerce or arts or languages, likewise. You have to select your subject scheme based on, maybe it's based on your results or maybe based on your choice. So anyway, there's a decision to be made. So usually in Sri Lanka, we see, I don't know what's the situation in Kandy now, but earlier days actually, so most of the students are trying to get through this A-level examination, and if they are not success, they are trying again and again. That means same thing you do again and again, which is normally in grade 13. That is called repetition. So that's called first choice, second choice, and third choice. They are trying to anyway get a good results and enter to the university. If it is successful in the first attempt, then only one time. But if it is not successful, then they will try for 2-3 attempts. So that is an example for repetition. So similar to that in programming also, even when you are writing, for an example, assume that you are writing in the Word document. After finishing one line, okay, let's write one line. I'm going to write one line quickly. Okay, after finishing this line, if you apply again, one, okay, then after finishing this line, so it will automatically go to the next line. So likewise, so repeatedly you do the same process. So selection is some example, like you select this one and you have to decide whether the font size is 11 or 12 or 14, likewise. You have only one option. You can select one at one time. If you select 18, it is 18. If you select 12, it is 12. You can't 12 and 18 both. Right? You can't select 12 and 18 both. You have to select one option. So, and font, same thing, selection. So in computers, you have sequences, selections, and repetition. Sequence means you write one letter after the another. And selection means when you have formatting, you have to do selection. Repetition means apply same things or follow same instructions again and again. That is called repetition. So if you have, I think you can remember now. Okay. So if you have any question, any doubt, please ask. Okay. I'm going to do this in English medium, but I'm not really fluent in English because anyway, I have even done my A-levels in Sinhala medium. But since your requirement is English medium, I'm doing this in English medium. But if you feel inconvenient or if you cannot understand anything, please let me know. Then I can explain Sinhala very well. Right? But thinking that you need this in English medium, that's why I'm doing it in English medium. Right? Okay, but if anything unclear, please ask, because my vocabulary is not really good to explain some technological aspects sometimes. Right, okay, then drawing flowcharts. draw in flowchart, write in pseudocodes, and conversion between them. Then we are going to do that today itself, and find an alternate solution to a problem. That means any problem you have to find alternatives. That is called feasibility study, basically. So single word for this is feasibility. Find an alternative. Alternative solution means what is the most feasible thing. So then evaluation of programming languages. So we will be learning one programming language, that is Pascal. But earlier days, we use language called machine language, which still use, we are still using that to instruct the computers and electronic devices, because computers cannot understand human language. So the smallest example is a switch. If there's a switch in your room to turn on a bulb, so that switch will understand only two status. What are those two status?
On and off.
On and off. So we represent that using 1 and 0 in computer. So basically we have mathematical symbols to represent that. So that language is called binary in mathematics, but in computing it's called machine language. Okay, the technique in mathematics is binary. So base 2 numbers. But technique in computing we call machine language. So that is the only mechanism to instruct a computer, on and off, or presence of electricity and absence of electricity. Or you can say high voltage and low voltage. Anyway, two kind of status. Those still computers understand those two status. Earlier days, the first generation programming language was focusing only about these two status. But later people understood this very difficult, because you have to tell letters in binary, then you have to explain graphics in binary, videos in binary, audios in binary, programs in binary, everything in binary. It's very difficult, inconvenient for the people, but even though it's convenient to the machine, so then they have developed programming languages. The second generation, they have used assembly language, which is symbolic representation of these binaries. Then third generation, they found that even this symbolic representation is difficult. Then they came up with a solution called high-level languages. In these high-level languages, basically it's like human language. When you tell print something, it will print. So that is similar to our human language. So that's how programming languages evolved, and we will discuss about that as well. Okay, that is the summary of this lesson. So do you need me to do all these things or any specific area of this lesson?
Specifically, I need to get the pseudocodes and the Pascal stuff done.
Right, flowcharts? You're okay.
Flowcharts, yeah, I'm fine. Flowcharts.
You're okay with that, right? Okay. So, right, then let me begin with giving few examples, basically. So if you're okay with flowcharts, that means surely you're okay with pseudocodes and programming languages like Pascal, because if you know flowcharts, the verb or structured English representation of the flowchart is pseudocode. Pseudocode is not a real code. It is just structured English. You write down whatever in the flowchart in structured English. So that is called pseudocodes. And then if you can write the pseudocode, if you know the syntax of Pascal language, it's very easy to translate pseudocode to Pascal code. Okay, anyway, so let me start with the background first. So before, yes, we will discuss that part, sure. But the thing, before we begin, let's start the background first. So I'll take a new document to explain that. So there's something called SDLC in software development. This is the next lesson actually. So what do you mean by SDLC? SDLC means?
Software development life cycle.
Yeah, software development life cycle. So this is sometimes called systems development life cycle. Systems development life cycle. Sometimes software, sometimes. So basically, generally, it's systems development life cycle. But when we specify this to software field, we call software development life cycle. Okay. So why this is a cyclic process? Basically, the first step of this is identifying the problem or the problem definition. There we identify what is the issue. Then the next one is requirement analysis. Even the problem, we found the problem correctly. requirements can be varied. Requirements analysis. I'm just reminding these things. Analyze. Requirement analysis. In this step, we find what are the inputs, outputs, and what are the processes, what are the decisions to be made, and all will be found. And all also, there's one thing, sub-step of this is feasibility study. That means you find out whether there are any alternatives. And then the system design. Then system development. Can you tell me the other thing? Then
you test the system.
Yeah, testing. Finally, after that, you have to hand over the system, that is called deployment.
Deployment.
Hand over the system which called deployment, and after that, so any system should be, it should be reviewed and maintained. These are the steps. If you follow these steps one after the another, we call that is waterfall model. If you repeatedly follow this as iterative way, we call iterative development. So when requirements are clear and stable, we go for waterfall model. But when system is critical and requirements are changing and requirements are not clear, we will go for iterative development. Sometimes in order to find out requirement, we have something called prototyping. Hopefully you can remember those terminologies. Can you remember those?
Yeah.
Right.
Yes, sir.
That is theoretical part. Okay, in here, so problem definition means you have to identify a problem. For example, assume that you, let's go to our past and let's say our ancient people. So their basic need was finding food, reproduction, as well as shelter. But when they were reproducing, when their generation was spreading, they had a problem of not having enough food items, not having enough food items. Then problem is not having enough food. But requirement for that was, so what was the requirement? Then they have to find out the food. So they wanted to travel from one place to another place, finding food. Then can you tell me the feasibility study related to that? They might have seen what other animals are doing. They might have seen that what other animals were doing. So they might study snakes. They are going through this. They are going somewhere, monkeys and all. They are using trees and fishes. They travel through water. Frogs, they jumps, and likewise they found various. There are various methods, but finally they understood that walking is the most feasible way because they are human beings. So walking is the most feasible one for them. And then according to this walking requirement, they need a kind of structure that is called road. So that's how the problem and requirement, even problem is food, requirement is road. So that's why it's very important to identify the problem and requirement. Requirement might not be the same as problem. So if you want to solve the attendance problem of a class, so let's say you have payment problem of a class. So, and you are the class teacher, you are not getting the payment on time, or you are not getting the payment correctly, accurately. Maybe the person who's handling these payments and all might cheat you. To stop that, you need student registration system to register all the students. Then you can track them. So the problem is payment, but the requirement is student registration system. Likewise. Then feasibility is student registration, whether it can be done in using a robot, whether it can be done using a barcode, using a fingerprint, or using a web-based system. That is the feasibility study. And system designing is the pace that we are going to discuss today. In system designing, we use some tools. What are the design tools used here? Design tools used here. So we are studying flowcharts and pseudocode. Pseudo codes. These are the design tools that we are going to study. After designing, we have to do the actual development. There only we have Pascal. That is in system development. Then system testing, you have to test the system by small units as small units, that is called unit testing. Then you have to test the system by integrating components together, which is called integrated testing. And finally, the system as a whole, that is called system testing. And after system testing, you have to give it to users and check whether users accept this. That is called user acceptance testing. Okay, then deployment can be done after user acceptance testing. The deployment can be done in 3 ways, basically. So it can be directly implemented. That means remove the existing system and direct implementation. Direct. Remove the existing system and deploy your system directly. Or you can parallelly do this. Parallel implementation. It can be direct or it can be parallel. So, or it can be pilot. So what's the difference between direct, parallel, and pilot implementation? Direct means you remove the system, old system, and implement a new system.
Yes.
What is parallel?
Parallel is like the old system and the new system.
Yeah, old system and new
together.
system running together. That's parallel. Pilot.
The new system only on like a selected area.
Yeah, selected area or selected people will be used to test the system, and that's called pilot. So more safer one is parallel or pilot. Pilot is more safe anyway. Parallel have actually more overheads because you have to do old system work and new system work both, but still safer. But direct is not really safe, but that is the fastest.
Yes.
And in RMM, that's where you release the areas updates, patches, and more. So this is the place you release updates, patches. So in Windows also you get time to time you get updates. In antiviruses you get updates time to time. That's the review and maintenance. And if this is not going to work out, sometimes you might think that this system is no longer usable, no longer efficient. Okay, for an example, in earlier days, I was studying. Yes, so when I was studying in my school, we learned DOS, disk operating system. So then Windows 95. But time to time it changed. Now we are using Windows 10. Why it was changed? Because they found that it is no longer usable. When they found it's no longer usable, then the only solution is upgrade. Upgrade means change in the grade or go for the next version. That's why this is a cycle. After review and maintenance, all the updates, all the patches, they will find that this is no longer, this cannot be maintained. So they will go for upgrade or the next level. So that is, again, you will go for the new problem and identify the new problem. For an example, the ancient people, the initial problem was solved, food issue. But then they wanted some convenient way of travel. Maybe they wanted to bring their animals or pets or whatever, because they were doing animal husbandry that time. Then they wanted some convenient method. That is the second problem, the convenience. The third problem is maybe more convenient. They wanted a road where it can less maintenance is there. Maybe they will add metals and all, and that is the next problem. Likewise, it evolved, and now we are using carpet roads and highways. But that's not going to end up because the current problem is traffic. So that's why still we are constructing roads.
Yeah.
So still we have problems. Okay, this is the big picture. In this big picture that we are going to learn this system design in PACE using design tools like flowcharts and pseudocodes. Not only these tools, we have some more tools, but unfortunately it's not there in your, unfortunately or fortunately, it's not there in your syllabus, right? So then we will learn these things, and I'll suggest you one tool which can be used to do this. That is, if you can just go through, so use this one. So in order to make this more interactively, you can use creately.com. Creately.com flowcharts. I'll search that. So this is the better smart draw alternative, creately.com flowcharts, which you can use in your computer to draw flowcharts. Right? Okay, so let's start with the problem then. quickly I will start with a problem or question. So I'll go start drawing now. I'll start with a question or the problem, and I'll transfer that problem to a program, a solution. Okay, basically this solution-based education is more common in other countries, but in Sri Lanka, this is kind of rare. But let's try for that, because no harm trying that. Okay, I'll try with a question first, then you suggest me the solution. So assume that I want to print, okay, design a system and develop to print odd numbers from 1 to 20. So design a system and develop to print odd numbers from 1 to 20. That is my question. So what are the inputs? Basically, you have to identify the inputs and outputs, plus processors and decisions. Can you tell me the inputs? So what are the inputs? I'm going to print odd numbers from 1 to 20. Any input?
Numbers.
Yeah, you can, but we are not going to input anything.
One.
So in this question, you cannot see anything like input odd numbers. So for the moment, I'll keep this blank. Outputs, you know, outputs 1, 2, 3, 4, 5, 6, 7. Sorry, not all of these. 1, 3,
1,
1, 3, 5, 7, 9,
5, 7,
11, 13, 15, 17,
15.
and 19. Those are the numbers. So what are the processors? So after printing the first, so let's add some additional things. Where to start? We have to start from 1. We have to finish or stop?
20.
Yeah, it's 19. No, you can say 20 is also okay, right? Okay. When it is less than 20 or 19 or 20, whatever. So then processors, when you start from 1, start from 1 is a process, and how you generate the next odd number? After 1, what is the next? After 1, what is the next? It is 3, no? So how to go to 3?
Yeah.
1 plus 2, no?
1, yeah.
You can say start from 1 and add 2. Start from 1 and add 2. Then decisions. What are the decisions? You have to stop where this number should be less than 20.
20.
So that is one decision. So that is the main thing, basically. Number should be less than 20. And this process, actually you have to go repeat the process. Repeat the process until this number or greater than 20. Repeat this until the number greater than 20. So you have to break down this problem. This is how you break down a problem. Right? Then you can draw the flowchart and pseudocode easily. Okay, I'll start with the, so without, okay, I'll go for this, but for the moment, I'll keep this for a while. So let's start according to the order in the book. So order says, first thing, there are 3 control structures. You said correctly. What are they? There are 3 control structures.
Sequence, selection, and repetition.
Yes, those are the first one, sequence. The second one is selection. And the third one is repetition. Sequence means instructions are executed one after the another. I'll give one example for this. So add, okay, input 3 numbers and print total and average. So that is sequence. Can you break down this to these things?
Yeah.
So what are the inputs? You are inputting 3 numbers. You can say N1, N2, N3.
N3.
Right? N1, N2, N3, or number 1, number 2, number 3. Any convenient variable. Any convenient variable which is meaningful, as well as there are some variable naming rules. What are they? You cannot start from a number. Hopefully you can remember these rules. Cannot start with a number. Cannot put spaces in the middle. Cannot put special symbols like this. Right? No spaces. No special symbols. And don't start with number. You cannot say 1, 2, 3. No, not like that. You have to start with a capital or simple letter. There's one special symbol allowed. What is that? One special symbol allowed, that is called underscore. This sign, when you press shift plus dash, you will get this one. Shift ekai minus ekai ge home make no underscore. This is the only symbol which is allowed. Okay, these are some rules, right? Can you remember or not yet? Not remember.
එච්චර නෑ සර්.
එච්චර මතක නෑ. හරි. So anyway, okay. So I'm relating this to Pascal, that's why, okay. So anyway, this should be meaningful. So main thing is this should be meaningful. I'll give this separately or insert this is special thing. So if you don't know variables, variable naming. So you have to remember these things, variable naming, no spaces between words. You can write down if you want. No spaces between words. No special symbols. Better to have, that is not a rule, but better to have a meaningful name. That is a good practice. That is not a rule, but still a good practice. So, but these are rules. Rules I'll highlight in, practices I'll highlight in yellow color. That's not a rule, but that is a practice. It's better to do that. This is a practice. And next thing is, variable name, no spaces between word, no special word, no, cannot start with a number. Cannot start with a number. And but numbers you can put it in middle or end, you can put. Can use underscore. Underscore means this one, this symbol. You can use underscore symbol. That is allowed. So these are the variable naming rules, and cannot use keyword. Keywords means, so which are is that these are reserved to the language, reserved by the programming language. So cannot use that keywords or the reserved words of the programming language. So those are variable naming rules. So here, that's why I am applying the technical things since we are in the last moment. That's why I have to tell all these things together. එහෙම නැත්නම් මට අර පිළිවෙලට හිමින් කියන්න තිබ්බා. මොකද දැන් ටයිම් එක අපිට තියෙන ටයිම් එකත් එක්ක අපි ටක් ගාලා ඔක්කොම හයිබ්‍රිඩ් අප්‍රෝච් එකකින් ඉගෙන ගන්න ඕන. So that's my plan. So as I said, if you feel inconvenient anytime, let me know. Then I can go slowly. Yeah? So I'm doing this a little bit fast way. Okay, the water නැත්නම් වේගي වැඩිද?
නෑ සර්. නෑ වේගي වැඩි නෑ.
හරි. Okay.
Shit.
So, okay, these are the things. And these are the special things. These are the special rules when naming this. And here input numbers and print the total and average. You have to start, no specific starting point. Anyway, you have to start with the inputs. And you have to stop after printing. And outputs will be, you can say output will be the total So tot and average. You can use short words, huh? Like this. Anyway, it should be meaningful. Tot and average. Process, you have to find out the total. Total equal n1 plus n2 plus n3 is a process, and there's another process, average, avg equal total divided by 3 is also a process. Decision, no decisions. No need to take decisions because this is sequence. Okay, this is how you divide that problem to first, according to the first control structure. So this is sequence, so no decisions, no specific starting and ending point. So you have processes, inputs and outputs. This is called the requirement analysis phase. This one, requirement analysis. That's where you find the basic requirements like inputs, outputs. No. Okay.
Okay.
Finish writing?
Yes, sir.
Okay. So then let's move. Let's move and create this sequence. Let's move and create this sequence. Input, total, average, decisions, and tree. So outputs, total, and average. Yeah, we are done. So let's go to this one. And I'm going to start. Now I have to, after start, I have to give the inputs. So I'm going to remove this thing. And I'll add inputs. So you can remember the symbols, no?
Yes.
So start, stop, it is a rounded rectangle or ellipse. Ellipse can also be used or rounded rectangle. Start and stop, rounded rectangle or ellipse. Input, output, it's parallelogram. Samantarashvakyan, parallelogram. That is for input and output. Here I'm going to input number 1, number 2, and number 3. Okay. Then no decisions. Therefore, I'm going to remove this. And okay, sorry. After this, I have to find out the total. There's a process. So if you feel that if you want to write processes in a single box, you can write down everything in a single box, but the order should be same. For an example, here total should be number 1 plus number 2 plus number 3. At the same time, you can write average equal total divide by 3. But remember this, if you are using capital N, N1, N2, N3, here also you should use N1, N2, N3, same capital letters. If you have used simple one, here also simple letters. Here TOT, I have used capital T, simple OT. Therefore, the second TOT also I have used the same. So you can't do something like that in simple in the top, and when it comes to middle, you can't make that capital. Whatever you have used, you have to repeatedly use that till you end the program. Understood?
Yes.
Okay. Then what's next after this? Start input numbers, find the total and average. Then you have to display it. No, display means output.
Oh.
Output you can write. Okay, output is you can say print or display anything, any word related to that. Print the total and average. Print the total and average. Total comma average. So this is the output. I'm going to draw an arrow from here to here. Okay, after that you can stop. So you can stop. Then just link this to okay, this is how you draw the flowchart. So you can draw this. start, input the numbers, total and average, print the total and average, and stop. Finish?
Yes, sir.
Okay, if you have finished writing, tell me, then I can go to the next one. Okay, then, so the next thing is converting this to a flowchart. Sorry, converting this to a pseudocode. Converting this flowchart to a pseudocode. I'm going to copy this flowchart. Okay, then I'm going to use this flowchart. This is my question. The first flowchart come here. Let me insert this. Insert, and I'm going to insert as a picture from file. And this is my flowchart. Okay, it's too large. Right, then I have to write the pseudocode, relevant pseudocode. Okay, I'm going to write it in front of this. Why I'm going to write in front of this? Because to show you that's how easy it is. First you have to start. And then you have to tell input number 1, number 2, number 3. Then, so next is this total equal number 1 plus number 2 plus number 3. And then you have to find the average. Average AVG equal total divided by 3. And then you have to display the total and display the average. And then end or stop or end. Some people sometimes they are using begin here. Begin and end. Okay, this is the pseudocode. Is it difficult or easy? The same thing you have to write
It's
without
easy,
saying. Yeah, it's easy. So can you finish this right? Can you quickly finish writing?
Okay. Okay, sir.
Okay. Right then. So let's go and code the Pascal code. Do you have you installed Pascal in your computer?
No, sir.
No. Okay, if you want, you can install this. There's a version called Free Pascal, and there's another one called Turbo Pascal in DOSBox. You can install this because practice this before the exam. That's very important. Turbo Pascal in DOSBox. Because this Pascal is very old program, right? Old programming language. So you have to run this inside DOS. So this is the one. I recommend this one. So if you are using a Windows computer, please download this Turbo Pascal with DOSBox, and then you can install it. Hello?
Yes, sir.
Okay. Turbo Pascal with DOSBox, and then you can install this in your computer inside DOS. It will automatically download DOS and install inside DOS. Because this is kind of all program. Or the second method, but in the second method, I'm going to use second method. But in this second method, it's difficult to give inputs. But you can practice the code. inputs දෙන්න බෑ. inputs දෙන්නේ නැතුව code එක practice කරන්න පුළුවන්. හේතුව program එක run වුණාට පස්සේ අපිට මේකත් එක්ක interact කරන්න බැරි වෙනවා දෙවෙනි method එකෙන්. දෙවෙනි method එක තමයි Pascal online compiler. Pascal online compiler එකේ තියෙනවා එක්ක යන්න පුළුවන් මේ onlinedb.com එකට. එහෙම නැත්නම් මෙන්න මේක මම පාවිච්චි කරන්නේ දෙවෙනි එක. tutorials point වල online Pascal compiler එක. මේකෙදි එකම අවුල syntax එකයි. All the syntaxes are same, but only thing is you can't give inputs real time. Instead of that, you have to give it as a variable. Right, let it load. And I can try for this one as well, but I'm not sure. I have not used that one. So it seems, okay. So this is your, it has loaded the first program. I think you can see that in my screen. Sorry. Can you see? Here this side?
Yes, sir.
Okay. So this is my first program. Actually, they have shown this. This is automatically they have given program hello world and begin write ln hello world. So let me run this, execute. This is online one. You can do this. You can use this even using your mobile phone. So that is the beauty, because nowadays it's not really required to have a computer to learn programming. Even your mobile phone can be converted to a computer and start programming. So this is, if you want, just write down the URL. It is tutorials.com/online_Pascal_compile_Pascal_online. Oh, I'll send this using the chat section of this one. I'm going to, okay, I'll send this chat section, then you can just copy that. Okay, then, so let me run this, execute. This is kind of slow because it's online, and it will print here. You can see it will print hello world here. Can you see the output?
Yes.
Okay, so then let's go to our program. So our pseudo code, if you can remember, this is my pseudo code. Input number 1, number 2, number 3, and total average and display total average end. That's all. It's in your book now. So let me begin. I'm going to write this. Then after begin, I'm going to write the variable section. I'll introduce my variables. N1 equal, I'm going to give the numbers, okay? Because I said that it's not possible to input, therefore I'm going to give the numbers same time. N2, let's give another number, and N3 is another number. I'm going to give that. Okay, then I'm telling total equal N1 plus N2 plus N3, and let's print the total. Let's print the total. Total is, and I'm going to print the total. Okay, let me run this. Okay, it has a, okay, it says, I think something wrong in our syntax. I cannot also use that. I have not used this long time, sorry for that. So what is that identify? I have to tell the variable type, sorry. So this is integer, no? Yeah, you have to tell the variable type. So let me go refer to your book quickly. And in this section, algorithm, and after that, so this is, okay, our pseudo code. And after that, it should indicate our, here, these are the keywords here, reserved words, they have given that. But no need to buy hard, just go through these things. So reserved here, this is what I said, identifiers. You can use underscore. So, but you can't use special symbols.
Yeah.
You can't use numbers in the beginning, no spaces in the middle, no special symbols. Okay, that part is given in your book as well. Here you can see the reserved word is var, and then the variable identifier, and then you have to give the data type. So that part I missed, and that is why it gives an error. So when you're writing program, first of all, you have to introduce the variable and give the type, right? Then only I can use that. So that's why I got an error. But variable is like a bucket. Variable is like a bucket. It's like your mug. So when you put tea inside, you call tea. When you put fruit juice, it's fruit juice. So when you put coffee, it's coffee mug. So mug is not going to be changed. Mug is a fixed location, but value or the data inside this mug or data inside this variable is going to change. Okay, that's the idea. So variable has a name and it stores value and declare type. It has a name, it stores value, and it has a type. So what we missed is type. Let me go and introduce the type. I have to tell that, first of all, I have to tell the type of variable. So we have this, sorry, N1, I can mention all these things together, N2, N3, and total are integer, in integer type. I have to tell the variable type, and then I have to tell this. The next one, average, is, so what's the data type for average? Is it integer or double real numbers? Integer means whole numbers. When you divide, you will get real numbers or double or float. Here in your book also it's given integer and average is real. Real means it has some decimal points. And then this Boolean means, what do you mean by Boolean? Boolean means true, false, yes, no. Yeah. Yes, no value, true, false value. You call Boolean. Char, characters, and then text, string. If you don't know, please write down. Even you can use the pencil and you can write down in your book. This is page number 20. So integer means, integer can purna sankhya, whole numbers. Real means numbers including decimal points. Dashama sankhya dana puluwa metan. Integer purna sankhya or whole numbers. This has decimal points, real. Boolean means true, false, logic data. Boolean වල දාන්න පුළුවන් yes the no the කියන එකක් විතරයි. True, false. Character means single character. Char means single character, one character. And string means text. String කියලා කියන්නේ text.
Okay, sir.
Okay, then let's move to our declaration part. Then we have introduced average should be, so here this is integer, let's simplify, it's real. Okay, then let's run this again. Still I get an error. What is that? Illegal expression, compiling mail present, tree one, the variable section. It seems the variable section. I have to mention this. So let's try. So now 5, 3 means again this. So let me check with code. We have used the same thing. Let's refer to a program. Actually, I cannot remember because I have not used this for a long time. And here you can see program. Okay, I have given that part var, then the variable part declared, and then the begin and now. Okay, sorry, that's a major mistake. So the begin should start after the variable declaration. It's major mistake. So you have to always aware of this syntax. Okay, I'm really sorry. In the variable part and then the begin end part. Let's try this again. This matters because not like other languages, some other language. So if you download IDE, it will show the error. Here you can see total is 91. You got the answer. Total is 91. Is it correct? 12 plus 34 plus 12 plus 34 plus this is 89 and 10, 90. Sorry, 74, 79, 80, 91. Correct, no?
Yes.
Can you see this? Okay. So you better write down this. So these variables, similar to this one, you can give after var keyword, you can give in front of that, right? Or you can give even the next line after var keyword. Okay, right line indicates the inputs and this curly braces input including it shows the comments, right? Adnum is the program name, and if it has input and output both. So this part actually that is the only thing that I cannot include this read number and read number part. I cannot include it in my online compiler. But if you are using Turbo Pascal in DOSBox, මේ read part එක දාන්න පුළුවන්. මට මේ read part එක දාන්න බෑ. හේතුව මේ read part එක දැම්මට මේකෙදි input දෙන්න බෑ. දැන් මම ඕනනම් මේක දාලා පෙන්නන්නම්. මේක දැම්මා කියලා inputs ඒ වෙලාවේ දෙන්න බෑ online compiler එකේ. හරි? ඒ කියන්නේ input දෙන්න බෑ අපිට දෙන්න වෙන්නේ direct value එකක්.
ඒක දැම්මොත් මොකද්ද?
මොකද්ද පුතේ?
ඒක දැම්මොත් මොකක්ද වෙන change එක sir? ඒක දැම්මොත් මොකක්ද වෙන change එක read number?
Yeah, it will ask from us. එයා අපෙන් අහනවා. For an example, I can give something like this. Okay, write enter first number and read this to n1. I can tell read this to n1. Write tell and enter first number, and then I can read it to n1 variable, this variable. Then no need to give value here. It will ask the value while running the program. මේ program එක run වෙන වෙලාවේ යා අපෙන් අහනවා number 1 කියන්න ලියන්න කියලා. Let me execute this. Okay, it's still running. I'll show this change using some other language because I have not installed this Pascal compiler in my machine. But if you want, you can try this with Turbo Pascal DOSBox. That one you can try. Next day I'll show this using my Windows computer here. So here you can see it stops. It stops and asking me the input. But the thing is, I cannot give inputs here. So I tried this, but it was not possible to give input here. That was the issue, right? But the thing is that I'll show this using some other language just to give you idea. But this is in your examination, you don't have this. I'm using ideally, this is Python. This is not Pascal. I'm going to write the same program, and this is anyway useful because any programming, if you have pseudocode, it can be converted to any programming language. So you can remember your pseudocode. No, this one is your pseudocode. Begin and this part. This is your pseudocode. Okay, if you have pseudocode, so you can write it in any language. That is the advantage. Okay, I'm going to write pseudocode here. So this is actually not Pascal. This is Python. Still I can say, okay, n1 equal in int input, then I can give the message similar to that one. Enter number 1. There are syntactical differences, but still the concept is same. What you have to do is you have to take this number 1. You have to take the number 1, then number 2, then the number 2, then number 3, now n1, n2, and n3, number 3. Then you have to calculate the total equal n1 plus n2 plus n3, and average equal total divided by 3. Then you have to print the total and print the average. So you can see the concept is still the same. Input the numbers, find the total, find the average, display total and average. That is the program, and this is how you write the same program in Python. So let me run this. So when I run this, here you can see it is asking me to give number. So that's the difference. තේරුණාද? අතන අපි කෙලින්ම මේ numbers තුන දුන්නානේ. එහෙම නැහැ, මෙතනදී අපිට කැමති numbers තුනක් එයා අහනවා. මම පළවෙනි number එක දෙනවා, first number, second number, third number. According to that it will calculate total and average. Understood?
Yes. Yes.
Right, but so this could have given in other way. Other way means මට මෙතනදිම දෙන්න පුළුවන්කම තිබ්බ ඕන numbers තුන. අර input විදියට නැතුව. ඒක තමයි අපි දැන් කරන්නේ. මේ input නෙමෙයි ඇත්තටම. මෙතනදී ඇත්තටම වෙන්නේ මේ process එකක් වගේ. You give numbers directly. So then when you run, it will directly print total and average. So that's the difference.
Yes.
Right? So in your book, they have suggested this method to give here input variables and then read those variables from user inputs. This part you cannot implement in online version. So that's the only difference.
Yes.
Right? But if you are using a Turbo Pascal, definitely you can add this part. Okay, this is your first program, and this, I think, since this is there in your booking, I'm not going to repeat the same thing. So first you give the program name, then the variable, declaration of variables and their types. Then in between begin and end, you have to write the program, and you have to write ln is the output and read is the input. Right? Write ln is the output and read is the input. Okay, so let's go to the program, and I'm going to remove this part. So when I remove this part, this will start working, right? When I remove this part, because this was the practical issue I got in this program anyway. So let me write n1 equal some number. Right, then let me write this, and it will give me n1 plus n2 plus n3 total and average. I have to find. I didn't mention that avg is equal to equal එක දාන්නේ colon එකයි සමාන ලකුණ. avg is equal to total divided by 3. avg is equal to total divided by 3. This is how you give total average, and after that you have to print the total and average. Write ln total and write ln average. Okay, now you can see the total. If I add this average part, so when you compile or run this, you can see the total and average both. So this is the program for first one, first flowchart. Understood?
Yes, sir.
Right. So only thing is here, instead of writing the same program, since you have to take inputs, you could have written something like this. Right? You could have written something like this. Let me write this. Okay, this is my program. I have variables, integer, real, and all. Then it's better to write down what is in your book. Means you have this read in part, right? Ln and read in part. I'm going to copy this same thing. Let's copy one and let me write it here. Okay, write ln and read in the same number. Sorry. Let me write like this. Write ln enter number 1 and read into n1. Likewise, you have to write and read. That means give message and get an input from user. Third one also the same. So can you write down this one? This is more appropriate because we are using inputs n1, n2, and n3. N3. I'll copy this here. Then you can see this with colors and clear to write. Finished?
No, sir.
Okay. Then let me try with the other compile also. I have another compile online one. Let's try with this one. And run this. No, still it generates the error. 711. 711 means this one. Let me write this in single quotation. Because in word single quotation is not the same as programming languages. That's why this error comes. Let me try with this single quotation. Let me compile again. Okay, still I'm getting right. Sorry, I have spelling mistake. Did you see? Right ln te write. If you have done the same, please correct it. Right ln. Spelling mistake. Okay, it's asking. This one is okay. Enter number. Let's enter a number 34. Enter a number 56. Enter a number 67. This is good. This one is asking. This is online GDB. That's why I said. So please do the corrections. Okay, I did small mistake here. Right ln te and you can see it's working.
Yeah.
So that's the difference. I'll use this one. So you can write right instead of right ln. Right ln නැතුව right ලියන්න පුළුවන්. එතකොට මේ ඊළඟ line එකට යන්නේ නැහැ. Here enter number 1 කියලා ඊළඟ line එකට යනවනේ. නේද? enter number 1 කියලා ඊළඟ line එකට යන්නේ මේ ln එක තියෙන ඉඳලා right line කියලා තියෙන ඉඳ ln. ඒක අයින් කරාම ඊළඟ line එකට යන්නේ නැහැ. Okay, you can see enter number එතනම නවතිනවා. Okay, then I can give number, this second number, third number also asking, and then it will print the total and average. That is more smarter. Rather than giving right ln, you can give right. Okay, now you can see, I think you can take a screenshot of this, or I'll also take this one to forward, then I can forward this to you. Let me send it to the chat section. Desktop. So I have sent the file, print screen. Let me know whether you got it. Okay, I think you got the message. You can check it. That is the screenshot of work in progress. You got it, Dinali?
Yes, sir.
Right. Okay, then let's move to the second one. So sequence, I think. So now I think you might feel somewhat okay. Somewhat okay means I think you can now understand what's really happening. So we came up with this one, flowchart.
Yeah.
According to flowchart, then we have planned our program. This is actually plan. This is not the real program. Then what we did, we have converted that to real program. When we converted that to real program, we got many issues. What are the issues? Language issues, basically syntax errors, lot of syntax errors. So if we include wrong syntax, it will give us an error, right?
Yes.
Wrong syntax, it will give an error.
Yes.
So likewise, we face a lot of problems, but logic is same. When you see the logic, it's same. So we have used the same order, same logic. You have taken the inputs. Okay. After taking the input, you have, let's go to the first one. Okay. So when you compare with this, flow chart, you got this flow pseudo code, and when you compare with the pseudo code, the actual code is logically same. Actual code is logically same, but the thing is that it has some syntax to include. For an example, var like keyword, program like keyword, begin like keyword, and then this write, read, write line, those are keywords. And when you make it equal to someone, total colon equal, so we have used colon equal. So these are the things. Understood? Okay, let's move to the next one, selection. So let's move to the second one, selection. In selection, so we will be discussing about some decisions. Okay, let's say something like this. I'll give a question. Please write down this. Write a pseudocode and draw flowcharts to input 3 numbers and find the maximum from those 3. Convert the pseudocode to a program code. Convert pseudocode to a program code in Pascal. Within bracket, I'm going to write Pascal. Okay, try to do this second one. Write pseudocode and draw a flowchart to input 3 numbers. First draw the flowchart, okay? First draw the flowchart and then write the pseudocode and then try for, I'll help, actually I'll help you. When you're writing the Pascal code, I'll give you help. So try to use the syntax, same symbols, and draw the flow chart first. You are going to input 3 numbers and find the maximum from those 3. I'll give you 5 minutes to try. Then I'll explain. Shall we start?
Okay, sir.
Okay. Let's start with the flow chart. So first go to this one and okay, here. Let's go to the creately. And now again you are inputting 3 numbers. And now you have to find the maximum number or the largest one. If there was only one number, what is the largest? If there was only one number, what is the largest?
That number?
Yeah, that number. So you can mention that if you want, like you can mention that. Or you can say if there max is number 1. If there was only one number, max is number 1. You can mention that, right? So
yeah,
if there was only one number, but since there are some more numbers, you have to. So let's input 1 first. Input 1 first. If there was only one, the max is the particular number. Then you need to decide. Actually, you are going to enter 2 other numbers. And then you are going to enter the second number. I'm going to write this one. Input number 2 in 2. And after inputting that second number, you can check whether this number 2 is greater than the max. That means already you have max. That is number 1. And you have entered another number. එක දැනටත් තියෙනවා max එකක්. max එකක් දැනට තියෙද්දි දැනට තියෙන කලින්ම enter කරපු number එක. එක්කෙනෙක් තියෙදියානේ max. Then the new number comes. When new number comes, it has to check whether the new number, this is number 2, whether it is even greater than the existing max.
yes.
මෙයා බලනවා තියෙන දැන් ආපු number එක තියෙන max එකටත් වඩා වැඩිද කියලා. So if it is greater than, okay, let me add this arrow here, this direction. Okay, if it is greater than, if it is yes, what do you have to do? You have to change the max to the new number. You have to change the max to the new number, which is max is number 2. If this is yes, only, if this is yes, this is yes, you have to change the number. Okay. If this is yes, you have to change the number max to this number 2. If it is no, no need to change the number. Okay, then after that, again, you are going to enter another number. That is your number 3. You are going to enter another number. That is the number 3. Here. I don't know whether you have done the same. I'm giving you a suggestion. But might be your answer might be better than my one. Let's check this. Okay. Input the next number. And again, you have to check. Again, you have to check whether this new number, that is n3, is greater than the max. Again, you have to check this n3 is greater than the max. Okay, if it is greater than the max, again, you have to do something, that is assigning this number 3 as max. Max equal n3. Now all numbers you have checked. Initially it was number 1, and then you check with number 2. If number 2 is greater than, you have changed that. And then you check with number 3. If number 3 is greater than, again, you have to change this number to max. So all these cases, after all these cases, if this is yes, Okay, sorry. Add this arrow. This is yes. Okay. If this is no, no need to do anything, right? So I'm going to connect these parts, other parts. So using this connector. If this is no, no need to do anything. Okay, this side you should have no. If this is no, you have to do nothing. Here also, if this is no, you have to do nothing. If this is no, do nothing. No, do nothing. Then, okay, if this is no, do nothing. If this is no, do nothing. If this is just maxis. Finally, you have to connect this one also to the, this one also to the same connector. Okay. Then after this, you can finish this code. I don't know whether you have drawn the same. Okay, let's change the arrow side, and this is an arrow and should be one side. Sorry. So this arrow should come. Sorry, I have to undo. And add arrow from here to here. So this arrow is coming wrong direction. Okay, let's connect this to this to this top junction and this to this one. Okay, now it's clear. So anything, any suggestion, any other method?
So what I did was I inputted all the numbers in the first place.
Okay, then?
And then like is number 1 greater than number 2? And then if not, is number 2 greater than number 3, and like that.
All right. How many decisions you taken? 2 or 3?
2.
2 decisions. The first place you check with number 1 greater than number 2. Okay. Then second place?
Yes.
If it is yes.
Number 2 greater than number.
Okay.
Then max equal number 1. Like that.
Right. I think the logic has some issue. Let me check. Okay. Let me write. First, you have checked if. Tell me the way that you have done. If number 1 greater than number 2. Then?
2.
Then what is the decision if this is yes?
Max equal number 1.
Max equal number 1. Okay. Else?
Else if number 2 is greater than number 3.
Okay. Else. Again if, right? Number 2 is greater than number 3.
Greater than
number 3.
Yes.
Okay, then?
Yeah.
Then max is?
Max equal number 2.
Okay, max
number
is number 2. Okay. Else?
I wrote max equal number 3.
Else max equal number 3.
Yes.
Okay. Okay, let's check. Sometimes this can be correct. So let's check. So let's say, let's enter the numbers 2, 3, and 4. 2. 2 greater than 3? No. Then it will come to else. Else, and then check whether 3 greater than 4. Again, no. Then it will be printing 3, which is 4. That is correct. So let's write other way. 3, 5, 4. 2, 5, 4. 2 is greater than, no. It will come to else section. Then again, it will check 2 whether 5 greater than, yes, then it is okay, then else. Okay, that will also find the number. Then 6, 3, 4. 6 is greater than 3, yes, then max is this one. And then it will not come to else section. It will not come to else section and it will print 6. Okay, something like this. Then what will happen? 6 is greater than 6 greater than 3, no?
Yes.
Then max is n.
Yeah.
Then it will not go to else section. See how the logic was. Then it will not go to else section. So first decision it will take max is 6. Then it will not check without checking the second decision. It will go for an answer. It will print max as 6.
Yeah.
That is the logic error. So sometimes you might not see that. That's why I said always try with some values. Try with some values, then you will get that. So, but you can correct this. You can correct this. You can correct by adding multiple points, maybe. You can correct by adding multiple things. You can check n1 with n2. If yes, this is n1, then inside that also, again you have to check if n3 is greater than n2. Then you can say max is n3. You are not just checking n1 with n2. After that, you are checking n2 this particular thing with. So for an example, n1, n2, then max is n1. Again, you are checking whether then you are checking with n1. You have to check with n1.
Yes.
Again, you have to check with m1. And again, in else part also, here else part also, you have to check with. Here you have, in this first one, you have else, no? In the else part, you have to check whether n2, the second part means this is max is n2. Max is n2 because if n1 is greater than n2, max is n1. Correct, no? But if it is not greater than n2, then max is n2. Max is n2 and you have to again check with this third number. If n3 is greater than n2, then max is n3. Then you are checking it all, no? But you have to check like 1, 2, 3 times.
Yeah.
මෙතනදි බලන්න n1 ලොකුයිද බලනවා n2ට වඩා. එහෙමනම් n1 තීරණය කරනවා max කියලා. හැබැයි n1 ව බලනවා n3ත් එක්කත් compare කරලා. So this one you are comparing with both. Understood? This one you are comparing with both and checking whether it's correct. So if first decision is wrong, so then the answer is this one, no? But this one, මෙයාට වැඩි එකක් වෙන්න පුළුවන්. For an example, second one is greater than this one. Let's say something like this. Then when you compare, 6 is not greater than, then it will directly come to else section, this else section. There it will say 9 is the max. But that 9 you have to compare again with 10. දෙපාරම බලන්න ඕන දෙන්නගෙම compare කරලා, then you will find no entry is the greatest one. Likewise, you have to agree. ඔයාගේ ක්‍රමෙත් හරි. හැබැයි එතකොට තව එකක් වැඩිපුර දාන්න වෙනවා මේ check එකක්. එකපාරක් check කරන්න වෙනවා, otherwise so it will give logic error. Understood?
Yes.
Right.
Yes.
So your one is not wrong, right? It is correct, but it is partially correct. So
Yes.
what you have to do is you have to check with both numbers, because one time it has taken blind decision. Blind
Yes.
decision, you saw that. Because of that, please put numbers and check. Okay. I'm going to refer back to the one I have suggested, but there are different answers. Okay, this is only one answer. So other than this, there are different answers. Here I have two comparisons. Two comparisons in this method. Only two comparisons. Because this connector, sometimes in your book you cannot see the connector. I saw this. මේ ඔයාලගේ book එකේ මේ connector එක අඳුන්වලා දුන්නට ඒක use කරලා නැහැ. Here let me show this for an example. Here you can see the connector. Can you see? Hello?
Yes.
Yeah. Connect. Even though connector is there,
Yes, sir.
here මෙතන connector එක පාවිච්චි කරන්න එපා. When there are two parts, multiple parts, you have to use the connector no here. But they have not used the connector. They have
Yes.
directly connected arrows. Right? Therefore, remember that in examination, this can be the answer. In answers, there can be this connector missing. But it's not wrong because it's given in the book. Book එකේ දීලා තියෙනවා මේ method එකත් හරි කියලා ගන්න වෙනවා. හරි සාමාන්‍යයෙන් connect එකකින් තමයි connect වෙන්නේ පැති ගොඩකින් එද්දි. මේක හරියට මේ වගේ. So සමහර junction වල roundabout තියෙනවනේ. සමහර junction වල roundabout නැහැ. So this is like junction with roundabout. But this is junction without roundabout. That is also correct. But still a junction. Right?
Yes.
Okay. So how to identify whether this is selection or repetition? So here, this is the example given for selection. Finding whether number is odd or even. So how they have done, input the number, divide by 2 and find the remainder. If remainder is 0, number is even. If remainder is not 0, number is odd. Okay, that's how they have done. Right. Let me know whether this, how to find out whether this is a selection or repetition. How to find out that? There's a trick. The make me raumata you can see all these are connected like a loop.
Yes.
But you can see these arrows will not form a loop. Why? You can go down, go right. You can't go up here. No arrows to go up. And when you come from the other direction, here going right, going down, but no way to go here. So therefore, this is just selection. But in repetition, there's a special thing. It will always form a cycle here. Come down, come down, come down, then go right and go up, again join here. There are continuous arrows. There are continuous arrows. So this is where repetition comes. Continuous arrows තියෙනවා repetition වල. හැබැයි මෙතනදී arrows තියෙනවා එකම පැත්තට නෙමෙයි තියෙන්නේ. Not one side. Arrow sign both sides. So you can't go like a loop. But here you can go like a loop.
Yes.
So that's the difference. Okay, here also they have not used the connector. Here also they have not used the connector. But still that is correct. Right, okay. Then let's go to this one. And now you know what is the solution. So you can draw this. Better draw this. I'll take a screenshot and can you draw this quickly? Or you can modify your answer also.
Okay, sir.
You can modify your answer if not. But this is also alternative. Where you are not going to input all numbers at once. You input one by one and check.
Yes.
I'll explain the code using both methods.
Yeah.
Okay. I'll explain the code using both methods. Okay, then let's move to the pseudocode part. I'm going to write the pseudocode here, code into that flowchart. So begin, then input n1, and you can say max equal n1, and then you can input n2. Then you have to compare if max is greater than, or if this n2 is greater than max, then max is n2. Right, then again, this is end if. Then you will have the next number, input number. If M3 is greater than max, then if N3 is greater than max, then max equal N3 and end if. Finally, you have to print or display max and end the program. Display max and end the program. So this is the pseudocode. You can also write pseudocode according to your one. Can you write down this one? Dinoli? It seems your microphone is muted.
Okay, sir.
Okay, quickly write down.
Okay, sir.
Right. So your one also you can write down, that is also correct, where you have to compare all, input all three numbers and then compare one by one. Compare n1 with both numbers, compare n2 with both numbers, and that is also valid method, right? So let me write down the program code then. Can you suggest me the program code? N1, N2, N3, and max are integers, correct? Hello? Can you hear me?
Yes, sir.
Okay. So is this correct?
Yes, sir.
N1, N2, N3, max are integers. Then I have to input N1.
Yes.
Hello, sorry for the interruption. I think now it's okay. Right, let me read the first number, then I can decide if So initially you have to tell max is equal to n1, and then if max or n2 is greater than max, then if n2 greater than max, then max is equal to n2. Max is equal to n2. Again, you are going to and if then same repeat again. You have to check with entry. Then entry. Finally, you have to print. The maximum. And that is your program. So let me write this or compile this, run this program. Okay, I'm getting an error. And if 17. If max is n2 is greater than max, then max equal n2. Okay, I have to check with the manual, sorry. Again. Okay, this is as if, then, else. Okay, if, then, else. You are not going to write end if, no? If, else only, not end if. End if is not there. End if will be there in pseudo code. So you are not going to write end if in this Pascal code. So it's, I'm sorry about that. Right, then you don't have this one. And this one too. Then run this. Okay, it's asking me enter number 1. Let's try it 45. Enter. You can write down this one. So you don't use, normally we are not using, so I'm sorry, I can't remember the syntax. That's my mistake because I'm not using this language. So you can write down this one. This is how you use Pascal. Basically, So you are not going to write end if here. So I'm referring to your book. In your book, you can see, even though end if is used here, here they are not using end if, else only. Here we don't need else part. Therefore, I have used if part only. Right? This one you can write down.
Okay.
When you compile, it will ask you to enter number. Then enter second number and third number. Then it will print the maximum number. I'll take a screenshot of this, then I can share this with you in case if you do any mistake. You can correct by looking at the print screen or screenshot. Finish writing? Okay. But when you, so basically writing, so this pseudo code, no need to worry. If logic is correct, that's okay. You will get the marks. And at the same time, if flowchart logic is correct, you will get the marks. But that other one, which is source code, we call source code. Source code means original program code. It's not like that. It's not like what we think. It's not like what we think, because you have to exactly give the same code. You have to exactly give the coding. Otherwise, it will not work. So here, this is the pseudo code, but here you have to give the exact code, even comma, dot, space, everything need to be considered. Understood? So what you have to do then? How to learn coding then? What do you have to do?
You have to often do it.
You have to go and do this. Yeah, you have to go and really code this. Otherwise,
Yeah.
that's why I said that I also cannot remember, because I'm not usually using this language. I'm using Pascal for teaching O levels only, because Pascal is now, it's outdated. So we are not using Pascal.
Yes.
But we are using some other languages like Java, C Sharp, VB.NET or C Sharp.NET, C++, and Python, Ruby on Rails, R. Likewise, we have some new set of languages to learn. So therefore, it's real, we use really. Therefore, we cannot remember the syntax. So, but in your case, you can't tell the same answer like me. In your case, you are the one facing examination and you have to practice the Pascal language syntax. But don't worry, they will not ask much. They will not ask you to write down exactly same coding. So if you have pseudocode or something similar to that, so assume that you have written this one, but with few mistakes, some comma, some spaces are missing, but still they will give marks. Don't worry about that, because they don't want to compile this and see whether it's running or not, because it's in your right. So that is ඒක ඒ හින්දා පොඩි chance එකක් තියෙනවා. But if you really want to write programs, then you have to write exactly same syntax, and that is very good method of practicing this. ඒ හින්දා දැන් අපි මේ කතා කරපු දේවල් ටික මේ flow chart එකේ pseudo code එක මේක ඒ වගේම පොඩ්ඩක් එක වෙනස් කරන්න පුළුවන්. වෙනස් කරන්න පුළුවන් කියන්නේ, so I can give you some homework. One thing is, so I'll send you some through WhatsApp. I'll send you some homeworks. So then you can just go through. I'll give you from sequence and selection. Repetition we have not yet discussed. I'll give it from sequence and selections. And meanwhile, try to follow the papers, 2017, 18, 19 papers. Try to find out the questions and do that. And anyway, that's in my paper discussion class. I have discussed those questions in my paper discussion class, but you said that you will not be able to come, no? It's in Sunday morning.
Yes.
It's in Sunday morning. That's why I had to arrange this class specially. And but anyway, you can refer to those videos because I have shared, and it's there in my
Okay.
YouTube channel too. So you can just go
Okay,
and watch that again and again. Then you can understand how to answer the questions. Right? We will discuss that later. Also, we have some. We can arrange few classes. No, we can arrange few classes and discuss about the papers. But before that, we have to finish the difficult part. No, that's why I said
Yes.
I wanted to discuss with you and finish the difficult part first, and then we can discuss the papers easily. Because I can assume that other parts are okay other than this lesson. But after discussing this lesson, maybe by next week, most probably we can finish this part. Next week or the next day, we can finish majority of the coding and sequence selection related thinking, excluding arrays. I think arrays we have to discuss another day. But maximum it will take 3 hours to finish the lesson, right? But I'm doing quite faster way. Still, if you cannot understand, let me know, then I can slow down and explain slowly. Okay then.
Okay.